So we begin the class. Very good day to everybody. This is algorithms 1, and in this class we discuss about how you try to multiply larger integers. So that is using Karatsuba algorithm for fast multiplication using divide and conquer approach. Okay, so this is especially for you, my dear students and young researchers, and you can reach me at dr.christoananth@gmail.com. So before beginning the session, once again let me thank God for giving me this opportunity to deliver this useful session to share my knowledge among my fellow national, international participants, students, and young researchers. In this class, we discuss about Karatsuba algorithm for fast multiplication using divide and conquer approach. We discuss about the divide and conquer strategy. Then we discuss about the C++ implementation of this Karatsuba algorithm for bit string multiplication and of course the time complexity. So I have already given the independent work for you. Please complete them. And at regular intervals, I will be giving you some short videos to discuss the knowledge in topics. Right. So let us take in the case we have two binary strings. Here, two binary strings will be having two values. You have to find the product of two strings. So let us take in the case if it is very small, you can actually perform it very easily. But if it is very large, definitely your Karatsuba algorithm would apply to it. For example, first bit string is maybe 1100 and second bit string is 1010. So let us take in the case 1100 it is actually 12 and second bit string is 1010 it is actually 10. So the output should be 120. So let the length of the two strings be the same and be n. So here we will be following a name approach that we will be taking all the bits of the second number and multiply it with all the bits of the first number. So finally you try to sum up or we add all the multiplications. And this is what you are going to take with this algorithm. Here it is going to take order of n square time. Okay. So this is the number 101001 41 and y 101010 that is actually 42. So here you are going to multiply. Okay, just like normal multiplication, you are going to multiply 0 multiplied by 1, 0 multiplied by 0. So that you are going to have, and similarly for the next one and for the next one, and finally if you add them you will be getting this number, and if you convert this one into decimal it should be 1722. Okay, so that is the same as the what you are going to multiply. Okay, so using this divide and conquer approach we can actually multiply two integers in less amount of time and the time complexity is also less. So let us take in the case we divide the given numbers into two halves. Okay, let given numbers be x and y. So here x is nothing but xl multiplied by 2 power n by 2, okay, plus xr. So here xl and xr are nothing but the leftmost as well as rightmost n by 2 bits of this x. So here we are going to divide it into half. Okay, and next one you are going to go with y, yl multiplied by 2 power n by 2, okay, plus yr. So this yl and yr are nothing but the leftmost as well as rightmost n by 2 bits of y. And here you are going to find out the product xy. So this x and then this y you are going to multiply. So that is nothing but 2 power n x y modulus, okay, plus 2 power n by 2 x l, okay, yr, okay, plus xr yl plus xr yr. So that you are going to multiply with this case. Okay. So if you can see there are 4 multiplications of size n by 2. And here we are going to divide this problem size n into 4 subproblems. Everything will be having n by 2. So that is the reason we are getting 2. Okay. So doesn't help because the solution of recurrence t of n is equal to 4t of n by 2 plus order of n. So here it is actually order of n square. Okay. So this one what you are going to do, you are going to change the middle two terms, okay, to some other form so that only one extra multiplication would be sufficient. So here you will have xl yr plus xr yl equal to xl plus xr multiplied by yl plus yr plus xl yl minus xr yr. Okay. So the final value would become 2 power n xl yl plus 2 power n by 2 multiplied by xl plus xr yl plus yr minus of xl yl minus xr yr plus xr yr. So this is the divide and conquer strategy that we will be using. So here now if you can see, if you can introduce only one extra multiplication, then that would be t of n is equal to 3t of n by 2 plus order of n, and the solution would be order of n power 1.59. So that is how you are going to actually reduce the computations. Okay. So what maybe let us take in the case if the length of the input strings are different and maybe not even. So for this one you have to append zeros in the beginning, and in order to have odd length then we put floor of n by 2. So this is how you are going to have it in the left half, and maybe seal of n by 2 in the right half. So maybe xy is equal to 22 seal of n by 2 xl plus 2 seal of n by 2 multiplied by xl plus xr yl plus yr minus of xl yl minus xr yr plus xr yr. So this is what you go with the Karatsuba algorithm, and you can use it for any base. Okay, maybe 2, 4, 6, 8 and so on. So this is a C++ implementation. So hash include IO stream, hash include std using namespace std function. Here you are going to make the equal length strings. So string ampersand str1, string ampersand str2. Then you specify the length. Okay, int length 1 is equal to string 1 dot size, int length 2 is equal to string 2 dot size, and you are going to compare if the length 1 is less than length 2. So for this case, int I equal to 0, I less than length 2 minus length 1, I plus plus. So string 1 is equal to, you are going to append the 0 to the string 1. Okay. Then you return the length 2. Else if case length 1, maybe it is greater than length 2, then for int I equal to 0, I less than length 1 minus length 2, I plus plus. Here with the case of string 2, you append 0. Okay. So 0 plus string 2 and return the length 1 if the length 1 is greater than equal to length 2. Then you have a boolean expression for the sum of 3 bits. So finally after multiplication, so in sum is equal to first bit power second bit power carry. Here you are going to append the 0. So the result is nothing but character sum plus result. Then you have a boolean expression for the 3-bit addition. So carry is equal to first bit ampersand second bit, okay, or second bit ampersand carry, or then you will have pipeline symbol first bit ampersand carry. So if there is an overflow, then you try to add the one to the previous, okay, the next one. Okay, so if carry of result equal to 1 plus result, then you return the result. Okay, so here you have a utility function to multiply the single bits of string a and b. So in multiply I single bit string a and string b, return a of 0 minus 0, okay, that you are going to have, then b of 0 minus 0. Okay, then you have the main function which is going to multiply the two strings x and y, and here you are going to return the long integer as a result. Okay, so long int multiply string x string y. So int n is equal to make equivalent x comma y. So base cases, if n is equal to 0, return 0. If n is equal to 1, return multiply I single bit of x comma y, and here you will have the first half of the string. So int fh is equal to n by 2. Okay, and then the second half of the string, it is nothing but n minus fh. So here string xl is equal to x dot substring 0 comma fh, string xr is equal to x dot substring fh comma sh. Then you will go with the first half and second half. So string yl is equal to y dot substring 0 comma fh. Similarly, string yr is equal to y dot substring fh comma sh. Then you calculate the three products. So long in p1 is equal to multiply xl then p2 xr then long in p3 you are going to multiply the add bit strings xr and then add bit strings yr. So xl and xr you are going to add, yl and yr you are going to add, and finally you are going to combine the three products in order to get the final result. So return p1 multiplied by 1 less than 2 multiplied by sh plus p3 minus p1 minus p2 multiplied by 1 less than sh plus p2. Okay. So here you will have the driver program printf multiply 1100 1010, similarly 110 1010, 11 1010, 1 and then 1010, 0 1010, 111 111, 1111. So maybe if you take in the case of this one 110, it is actually 12, and maybe 1010 it is actually 10. So your answer would be 120, and for this case it is 110 is actually 6, and then 1010 is actually 10. So 6 multiplied by 10 it's actually 60. Here 3 multiplied by 10 it is 30, 1 multiplied by 10 it is actually 10, 0 multiplied by 10 it is actually 0, 7 multiplied by 7 is actually 49, 3 multiplied by 3 you get 9. Okay, so that is the answer you will be getting in the output. So this is the time complexity. So here order of n power log 23, it's actually we already discussed, it is order of n power 1.59. Okay, so especially for the time complexity, you can generally improve it for the case of fast Fourier transform. So let us take in the case this is a long binary input, second binary input. So decimal output you will be having not representable, but definitely your output it will be calculating based on the Karatsuba algorithm. So this is the first binary input 1011. Okay, so here we'll have second binary input 1000. Okay, so if you can observe, this is actually 11. Okay, and this is actually 8. So decimal output would be 88, and output would be, your general output would be 5 e power minus 0. So this is the equivalent word for you. With the help of any programming language, exhibit the output of the closest pair and convex hull problem, so that you will be posting them in the Google Classroom.